Alright guys and gals, this is a video to help you with the classwork that you're going to do on Friday while I'm not here. There's 16 questions, I believe. They're all different kinds. Some of them deal with law of sine, some deal with law of cosine. Some might be just plain trig problems, but most of them are going to deal with law of sine and cosine. Before we get started with the problems, what I'd like to do real quick is just to write down there we are. Just to write down the different laws, so that way you can see them real quick in case you don't have a textbook or something with you that you'll be able to reference as we go through this. So let's start off with law of sines. So the law of sines looks something like this. It tells us that if we have, for example, the sine of angle A over side A, which is across from it, opposite it, that could equal, helps if I could write. Let's see, the sine of B over B, and then the sine of C, notice capital C, over lowercase. Again, all of these are angle measures. All of these are sides opposite those different angles. All right, so there's the law of sine. Now, law of cosine, there's actually three different versions of the law of cosine, depending on what sides and angles that you know, don't know, that kind of thing. I'm just going to write out one of them because ultimately they're all the same. And we'll talk about real quick how to memorize them. All right. So law of cosines look like this. It says if you have a squared, remember that's a side, that is equal to b squared plus c squared. So notice it looks a lot like the Pythagorean theorem, but remember the Pythagorean theorem would have a and b on the same side, with c on the other side. So again, we got a squared equals b squared plus c squared minus 2bc multiplied by, in this case, the cosine of a. So let's look at this real quick. So again, one way to help you remember this is that we've got the Pythagorean theorem here, but instead of c being on its own, we've got a. So again, a squared equals b squared plus c squared. Notice that in all cases, regardless of which sides and angles you have, the two sides that are listed here and are squared are also the two sides listed here next to the 2. And notice that the angle listed here, cosine of angle A, the side that goes with it is over here. So notice these A's bookend the entire formula, and then your other two sides are simply in there. So memorizing this is pretty easy. The first part looks like Pythagorean theorem. The second part is you've got just BC, or whatever the other two sides are, listed together with a 2, two of them. All right, the other two sides helps you remember. And then again, this angle and this side should be opposite each other, and they bookend the whole thing. Now, obviously, you could rewrite this with b squared equals a squared plus c squared, and so on, and get those other two renditions, but I'm just going to list the one. So again, we're going to use this card throughout the video just to help us see, hey, what are the different laws, whether it be law of sine, law of cosine, etc. So let's get started. Our first one here. Three cities form vertices of a triangle. The angles of the triangle are 40 degrees, 60 degrees, and 80 degrees. The two most distant cities are 40 miles apart. How close are the two closest cities? Round your answer to the nearest tenth of a mile. A lot of you aren't rounding appropriately, so make sure you do. So let's just draw a picture. I'm just going to draw a nondescript triangle. I don't really care if it's accurate or not. And we're told all of our angles. So we've got a 40-degree angle, a 60-degree angle, an 80-degree angle. Okay. And then it says the two most distant cities. Let's think about that. The two most distant cities are going to have to be on the side opposite the largest angle. Remember, largest angle is opposite the largest side. So the two most distant cities are here and here. And again, I'm using these x's just to represent the cities, not a variable. And we know that it's 40 miles apart. All right, so this side is 40. How close are the two closest cities? All right, well, now we need to figure out which side would be the smallest side. Well, again, the shortest side, the smallest side, is going to be opposite the smallest angle. So this, and I'm going to call it y, since we've used x's to represent our cities there. This is the side we're trying to figure out. So the question is, how are we going to do this? Now, whenever you're working a problem like this, this is the way I would recommend that you do. First, if you can use Pythagorean theorem or your special right triangles, do it. Unfortunately, in this case, that won't work. The next thing you should reach for is just basic trig. But remember, basic trig requires us to have a right triangle. We don't have one. So your last line of defense is either law of sine or law of cosine, okay, whichever one you ultimately need to use. In this case, notice I've got angle in a side I don't know, angle, and a side I do know. So that seems to fit best with law of sine. So that's what I'm going to use. So for example, we could say that sine of 80 over 40, because again, those are opposite, equals sine of 40 over y, okay, that side I don't know, and we can work this from here. So real quick cross products here, we'll get y sine of 80 equals 40 sine 40 as well. I'll make sure I hadn't made a mistake there. How interesting the two numbers work out. Then we'll divide it, so we know that our short side is equal to 40 sine 40 over sine 80. Now again, with calculator, and I'm going to use a scientific calculator just because I got one handy. When you're typing this stuff in, do your numerator first. So 40 sine 40, hit enter. Okay, don't bother doing the division just yet. Then when you hit divide, do so immediately. It'll automatically enter the last answer. Parentheses, always put parentheses in this case, sine of 80, close parentheses out, and here we go. We find our answer, again, rounding to the nearest tenth of a mile. For number 1 here is 26.1 miles, and there we are. All right, so this is the law of sine scenario. All right, let's try number 2. Where is number 2? Here we are. All right, so number 2, notice we've got a diagram for us, so we don't have to diagram it ourselves. Let's see what it says. Gail was visiting an art gallery. In one room, she stood so that she had a view of 2 statues, one of a man and the other of a woman. So notice here, those are labeled. She was 40 feet from the statue of the woman and 35 feet from the statue of the man. The angle created by the line of sight to the 2 statues is 21. So it looks like our person, Gail in this case, is standing there at the vertex. All right. What is the distance between the 2 statues? Round your answer to the nearest tenth. All right, so we got to keep doing that. So in other words, what we're trying to figure out is what is this distance that I've put in here by the dotted line. All right, so again, let's see what information we have. I'm going to represent this as an x, that distance. All right, so I have an angle across from a distance I don't know. Okay, I have another angle I don't know across from a distance, or another angle I don't know across from distance. Well, based on that, it looks like the law of sine isn't going to work, because notice somewhere in here, let's say we use these first 2, I'll either need 2 angles in one side or 2 sides in one angle, and I'm seriously lacking here. So if that doesn't work, the last thing we want to reach for is law of cosines. So as it turns out, this situation is going to work really well here. So notice how I'm going to fill this thing out. Let's scoot this down. There we go. So notice, I know the angle for here, don't know what's across from it. So when I fill this out, here's the only place I have for an angle, so I'm going to use that. The side that I don't know opposite it is going to have to go here, because cosine of A and side A, they match up. These match up, so that's where it needs to go. So let's start writing it out. So I'm going to have x squared equals, now I need my other 2 sides. So in this case, 40 squared plus 35 squared minus 2 times 40 times 35 times cosine of my angle, and in this case we said our angle is 21 degrees. So in this case, the law of cosine, while kind of lengthy, isn't all that bad, because all we're going to end up doing is putting it in our calculator. All right, so let's do that. So I'm going to type it in exactly as I see it. 40 squared plus 35 squared. 35 squared. Got to make sure you're entering it in correctly. Minus 2 times 40 times 35 times cosine of 21. Hit enter. And we get that. So I'm going to write it down. X squared equals roughly 210.97. Now notice, I'm just writing this down for myself. This is not my answer. I still have to get this squared to go away. So immediately I'm going to hit second, square root, second, answer. So that way it takes that full answer, not this rounded version, and I can take the square root of it. So according to my work here, our x, our distance here between the 2 statues, is 14. Let's see, we're rounding 2 tenths. So 14.5, what were we measuring in feet? So 14.5 feet from the statue of the man to the statue of the woman. All right, and again, law of cosine is what we used. All right, well, let's jump on to number 3 here. All right, number 3, another diagram. It's a good deal. Find x. So let's see where x is. X is between E and F, so there it is. Round angle measures to the nearest degree and side lengths to the nearest tenth. Looks like we're finding a side length, and it said side lengths, so we need to round to the nearest tenth. So we just need to find that measure. All right. Well, let's see. Is it a right triangle? Well, if I add my 14, and 67, and subtract those from our 180, nope, 99 degrees, so it's not a right triangle. We are going to have to use either law of sine or law of cosine. Let's see which one we can use. I know that I have 14 degrees here. That's opposite of x. I have 67 degrees here. That's opposite of 14, which I do know. So notice only one unknown, meaning I can use law of sines. So here we go. I'm going to say sine of 14, since it's there, over x equals sine of 67 over 14. And there we are. Little cross products, so 14 sine 14. I hate that they keep doing that because it looks weird when you write it down. And then let's see, x sine of 67. Divide by sine 67, and I'm going to rewrite this a little bit. X will equal 14 sine 14 over sine 67. All right. So again, when I'm typing this into my calculator, again, do the numerator first. So 14 sine 14, hit enter. And then immediately after that, hit divide sine, there we are, of 67 degrees. And there we are. So we find the measure, again, we're rounding to, what do we say, to the tenth, so we'll have to round up here. So x is 3.7, let's see, oh, didn't give us a unit of measure. So we'll just say 3.7 units, since we're not sure if it's feet or inches or what. All right. So again, another law of sine situation. All right, well, let's try 4. There it is, another diagram, which is nice. Real quick, let's see if it's a right triangle or not. So I'm going to take my 180, subtract the 56, subtract the 34. What do you know? That means this is a 90-degree angle, which means we could potentially use trig. All right, so let's see what it says. Find x. So that's another side length. Round angle measures to the nearest degree and find side lengths to the nearest. Again, we're finding a side length, so we need to find it to the nearest tenth. Well, notice, since that is a 90-degree angle, we don't necessarily have to use law of sine or law of cosine. We got it in screen there. We could use trig if we wanted to. So notice, I've got this 34-degree angle. X is opposite it. So we could set it up as law of sine and cosine. We've got exactly what we need. However, I could say, for example, notice I've got x here, 19 here, and maybe we'll use the 56-degree angle here. So that's opposite over adjacent, so I could say tangent of 56 is equal to, again, opposite 19.1 over x. We could do a little reworking there and ultimately find that x is going to equal 19.1 over tangent of 56. Again, to get here, I just multiply both sides by x and then divide both sides by tangent of 56. So I could type that in instead of using, say, the law of sines. Both would work. So let's try it. So in this case, I'm just going to hit 19.1 divided by tangent of 56 and see what we get. Again, we're rounding to the nearest tenth, so it looks like x is going to be 12.9 units. Okay. You could have, let's turn this a little bit here, we could have used the 34-degree angle. So again, that's opposite over adjacent. Still use tangent, in that case of 34. Or you could have used, again, the law of sines and gotten there just as well. I like using trig, so I'm going to use trig when possible. All right. So there's number 4. All right, let's do number 5. All right, with number 5, let's see. Find x. So there it is, another side length. Round angle measures to the nearest degree, side lengths to the nearest tenth. So we're finding a side length. I'm going to underline it just to make sure I do it. Let's see. If I add those together, I don't think I have any hope of getting to 90 degrees, so definitely not a right triangle. Let's see what we've got. I've got an angle across from a side I don't know, and an angle across from a side I do know. That sounds suspiciously like a law of sine situation, so we're going to use it. So I'm going to say sine of 61 over x equals sine of 42 over 127. All right. So from there, we'll just do a little reworking here. 127 sine of 61 equals x sine of 42. And then a little reworking here. I'm going to divide both sides by sine of 42. So x is going to equal 127 sine of 61 over, once we divide both sides by sine 42. So x will equal, here we go. Oh, here we got everything in screen. So again, do the numerator first. So 127 sine of 61, hit enter. There it is. Immediately hit divide, sine of 42, hit enter. And again, we are rounding here to the, what did we say, tenths position? Well, notice there's nothing there, so we could just say it's 166. Technically, we'd write 0.0, but you don't have to. So 166.0 units. And there we are, number 5. All right, well, let's keep going. Oh, where's number 6? My kingdom for number 6. Here it is. All right. Finding x again. Round angle measures to the nearest degree. It looks like it's an angle measure, so we're going to round it to the nearest degree, and we'll ignore about side lengths. So notice I've got an angle across from a side I know, angle across from a side I know. What do you know? Well, it sounds like a law sine situation to me, so let's use it. So I'm going to say sine of x over, the side opposite it is 9.6, equals, and then let's see, sine of 43 over 27 and 4/10. All right. So let's rework this. We're going to multiply 9.6 here on both sides. So sine of x equals, let's see, 9.6 sine of 43 over 27.4. Now again, we're finding an angle measure, which means we're going to have to use the inverse sine function to get rid of the sine that's sitting over here. So let's do that. So x is going to equal inverse sine of all this. So 9.6, 0.6, not 9.9, there it is. 9.6 sine of 43 over 27.4. Now, entering this into the calculator. Let's talk about it. First thing you want to do, again, is the numerator. So 9.6 sine 43. Hit enter. Okay. Immediately divide by 27.4. Hit enter. Again, immediately we're going to hit second, inverse sine, second, answer. So that way we keep everything together, no rounding as we go. And ultimately, let's see, what are we rounding to? The nearest degree. So we're going to say that x is, we'll call it 14 degrees. Again, because that's what we were told to do. Round things to the nearest degree. All right, number 7. Here we go. Again, find x. Round angle measures to the nearest degree. That's what we're going to do. We don't have a side that we're looking for. Again, we've got an angle opposite a side that we know, angle opposite a side that we know. The only thing we don't know is that one angle. It's another law of sine situation. So again, put the card out here for you. Law of sines. This is what we'll be using. So sine of x over our side length of 5.8 equals sine of 83 over 14. So we'll multiply 5.8 on both sides. So sine of x equals 5.8 sine of 83 over 14. And then we'll use the inverse sine. So x is going to equal inverse sine of 5.8 sine 83 over 14. All right. So x is going to equal, let's see what we get. So again, as you're typing this in, make sure you use your denominator first. So 5.8 sine of 83, hit enter. Divide by 14, hit enter. Second, inverse sine, second, answer. And we're going to find it to be, let's see, what are we rounding to? Nearest whole degree, so call it 24. All right, so there we are. So that was number 7 on our program there. So let's move it up here. We'll take a look at number 8. Gosh, this looks familiar. Again, another angle. Side we know, angle. Side we know one angle, just missing one. Looks like we're rounding again to the nearest degree.